In this video, we're looking at percentages in pie charts. We have two pie charts describing how a person's income is divided into individual expenses: car, housing, food, bills, and other. Each of these pie charts, the percentages add up to 100% to represent the entire, in this case, we'll refer to it as monthly income. We have another pie chart on this side that has the same expenses: car, housing, food, bills, and other. They're pretty similar. The differences that we'll be focusing on will be car and housing, and primarily car. Now, seeing that this person's budget uses 15% for the car, while this person uses only 10% of the car, are we able to say which person is spending more money on their car? So can we figure out which car belongs to which budget? Now, just in case you're thinking that the person owning this car would actually need to pay more per month than the person owning this car, let's actually assign some dollar amounts. So one car costs $30 per month, the other is $100 per month. Now, would you still say that the person who is only spending 10% must have the cheaper car, and the person spending at a higher percent must be spending it on the more expensive car? We are not able to say that at all. We actually cannot figure out for certain which car belongs to which budget. Just because we know the percents, it does not mean we can figure out actual amounts. Even if we look at percent one being larger compared to another, we still don't know that the two pie graphs are based on the same reference value. What we don't know is that this person's total income is $1,000 per month, and this person's total income is only $200 per month. These two quantities are the reference values for these two pie charts. And now we can calculate on this side 10% of 1,000. So 10% is 1/10. And dividing by 10 we know is really just about moving a decimal point. So from 1,000 to 100. And there's our $100 per month. On this side, 15%. Let's demonstrate multiplying by the decimal this time. 15% of 200, we can multiply 0.15 times 200, and we'll get the $30. So knowing the reference value is critical for when we compare percentages. In this case, the percentage that was spent on the car, or this piece of the pie, was smaller than this one, but this was actually a much larger pie, because it's the higher total income. So this was actually 5 times larger, so the piece is smaller compared to this piece, but understand it's part of a much bigger pie, so it's actually a greater amount of money. This is what the graphs might look like if their size reflected their reference values, one being 5 times larger than the other. And here you can even see that the slice that is 10% of the larger pie even appears to be larger than the 15% of a smaller pie. And that's exactly what we saw in those costs per month for the cars. One was only $30, even though it was a higher percent, while the other was $100, but a lower percent. Now let's go back to these examples. This was just after we decided that this car had a $100 per month expense, the other side $30 per month. Before we decided that the reference values were different, we actually have enough information right now to calculate those reference values. Think of what we know about calculating percents. Once we knew what that total income was, let's just use capital I to represent the total income, we multiplied by the percent, 10%. We actually did multiply by 1/10 to move the decimal point, and it equaled $100 per month. We can use what we know about this formula and about multiplication in general, that we can find out a missing number in a multiplication if we do the opposite operation, divide. So we could say that if I times 1/10 is 100, then 100 divided by 1/10 is going to equal I. It's an opposite operation, so instead of multiplying by 1/10, we'll go over to the 100 and divide by 1/10. And that will give us a number that equals the income, and we got 1,000. On this side, we were calculating 15%, and we multiplied by the decimal in that example. I times 0.15 equaled our car monthly payment, $30. So if we know that the income times 0.15 equals 30, then 30 divided by 0.15 will equal that total income. And we can see in this way that the total income was $200. So the bottom line is this. If we are looking at pie charts that have percents, but there is no given reference value, then we really don't have enough information to think about what these pieces of the pie represent. And when two pie charts have different reference values, we shouldn't automatically compare the size of the pieces, the percentages, because a smaller piece with a larger reference value could actually equal more money. Let's go through one more example, and this is a good problem for you to try. So pause the video and try this problem. We want to come up with the missing quantities. For each budget, we want to know the total income and then the actual amount spent on the car and the amount spent on housing. For this chart, we know that the total income is $1,300, and that's our reference value. On this side, we only know the amount of the car, that it is $300 per month. So we can calculate the missing values using the steps that we just went through with the previous example. So pause the video and try it, and now we'll look at the answer together. On the left side, knowing our total income, the reference value, we can multiply or divide to find these percents. The car is 25%, which we know is 1/4. 1,300 divided by 4 will equal $325. Now remember, this is the same thing as multiplying by 0.25. This might be our more familiar way of calculating percents, but remember 25 is 1/4, so it might be helpful to remember that sometimes too. So this side spends $325 per month on the car. What is the amount spent on housing? This time it's 35%, which equals $455. Now on the right side, we do not know the reference value yet. We don't know the total income to be able to calculate a 40% of that. But we can use what we know about the car payment, that it's $300. That if we took 10% of the total income, it would equal that amount, $300. So divide 300 by 0.10, or multiply by 10, to equal $3,000 for the total income, and our reference value for this pie chart. And now that we know the reference value, we can calculate the 40% that is housing. And really quickly, if you were saying 40% is 4 times larger than 10%, so the housing must be 4 times as much as the car, that's perfect. Absolutely, that's a good way to go. It is a great example of how pie charts are useful, to compare one slice of a pie to another slice of pie in the same pie. So we can definitely say that for this single person, 4 times as much is spent on housing as compared to the car, because 40%, 4 times larger than 10%. But without that reference value, we're not able to compare two different pie charts. So let's get back to this one and get some closure. 40% of 3,000 equals $1,200.